A triangle has a perimeter 13. Okay, they're not giving us any figure this time, so I've got to either draw my own triangle or just picture it. I don't have enough. I really like drawings, but I don't really have enough information yet. All I know is it has a perimeter 13. The two shorter sides have integer lengths. Again, I had a problem recently where I messed up on the fact that one of the variables had to be an integer, and so I'm extra sensitive to that now. So when I see integer, I'm highlighting that for myself. Integer lengths equal to x and x plus 1. Well, I've got enough information now that I guess I can label it. That kind of looks like an equilateral triangle, but I just know my figure is not necessarily drawn to scale, and it's not necessarily acute. It could be an obtuse triangle, but at least I know all three sides, x, x plus 1, and 13. I've got information about them all. The two shorter sides have integer lengths. Two shorter sides. I missed that in my first reading. That may matter. Which of the following could be the length of the other side? We have to use the triangle inequality that two sides of a triangle always add up to more than the other side. Which of the following could be the length? Oh, wait. I messed up here. Triangle has perimeter. I was thinking one of the sides was 13. No, the total perimeter is 13. X plus 1, and y. Well, I know that any two sides, I know that 2x plus 1 is larger than y. I also know that x plus y is greater than x plus 1, because any two, this plus this, has to be larger than this. Larger or smaller? Larger. Yeah. And this plus this has to be larger than this, because if it's the shortest distance, I mean, this is the triangle inequality is kind of another way of just saying the well-known property that the shortest distance between 2 points is a straight line. So the shortest distance between this point and this point is the straight line, which has length x plus 1. Well, any other path that I take to get from that point to that one, if I go here and then I go here, that's a longer path. So x plus y has to be longer than the shortest path between 2 points, which is x plus 1. So x plus y has to be larger than x plus 1, and all the way around. A triangle has three triangle inequalities based on which side you put on alone on the right-hand side of the inequality. I mean, x plus 1 is greater than y. That's the same thing here. And one of these is kind of implied by the other. X plus 1 plus y is greater than x. This tells me that y is greater than 1. This tells me that y plus 1 is greater than 0, which is kind of silly, because that just means y is greater than minus 1, but I already knew side of a triangle has to be positive, so this doesn't really tell me anything. Y is greater than 1, that tells me something interesting. 2x plus 1 is greater than y. Okay, I don't know if this is going to answer my question or not, but 2x plus 1 is greater than y, which is greater than 1. Well, 2x plus 1 is greater than 1. Oh, that doesn't tell me much. That tells me 2x is greater than 0. Whoop-de-doo. But I do know, I mean, this is the, probably the most interesting thing here. Which of the following could be the length of the other side? Oh, I also know that 2x plus 1 plus y equals 13. So I need to satisfy that and satisfy the triangle inequality at the same time. I'm kind of tempted just to, despite all of these inequalities that I just wrote out, part of me is backtracking and is tempted to do trial and error here. Let's say that, well, if y equals, see, that wouldn't work. If y equals 10, then x is going to have to equal 1. Without writing out the algebraic manipulations, I can just see if y is 10, 10 plus 1, 11, I'm going to need 2 more, so I'm going to set x equals to 1. And having a triangle with sides 1, 2, and 10, that's not going to satisfy the triangle inequality. I can't have 1 plus 2 is larger than 10. Kind of at the opposite extreme, what if y equals 2? If y equals 2, then 2 plus 1 is 3. X is going to have to be equal to 5. X plus 1 is 6. And this, I think, will satisfy the triangle inequality just fine. 2 plus 5 is larger than 6. 2 plus 6 is larger than 5. 5 plus 6 is larger than 2. I'm starting to think that this is my answer here. I was expecting my answer. You'll notice I tried E and then I tried A. I was expecting my answer to be at one of the two extremes, because when they say, there's a limited amount of information here, and it just seemed that my triangle inequalities were kind of going to bound me on one edge or the other. Either y was going to have some upper limit, or y was going to have some lower limit. And so I was just tempted to try the two extremes, and this one failed. This one seems to have succeeded. I could try another one. I could try y equals 4, in which case 4 plus 1 is 5. That leaves, if I bring all this to the other side, that leaves 8. That means x is going to have to be 4. Right? X plus 1 is 5. 5 plus 4 is 9, 13. Yeah. Oh, wait a second. The two shorter sides have integer lengths equal to x and x plus 1. These guys are not shorter than this guy. These guys are not shorter than this guy. I've got to go... That's actually not going to work. That's not going to work. If I have y as 6... There's another way. I think I could do this with pure algebraic manipulations on my inequalities, but I've kind of gotten into just trial and error mode. In some ways it was, I don't know if it's laziness or what, I just felt like I could, rather than manipulating inequalities, I just wanted to actually work with the numbers. I don't know, maybe I was just in the mood for that. We see the pattern here. Every time x is decreasing by 1, x plus 1 equals 4. This sides add up to 13. 6 plus 3 plus 4 is 13. And these two guys are definitely the shorter two sides. And does any triangle inequality satisfied? 6 plus 3 is larger than 4. 6 plus 4 is larger than 3. 3 plus 4 is larger than 6. So this is a valid triangle. Yeah, I think that one's good. And just let's do one more. Y equals 8, x equals 2, x plus 1 equals 3, this adds up to 13, and look, we've got a violation of the triangle inequality here because 2 plus 3 is less than 8. So this indeed is the only one that makes for a valid triangle. I have to satisfy 3 triangle inequalities to get a valid triangle. But then I also have this additional constraint that I almost glossed over, but I was careful to go back and reread the question. The x and x plus 1 are the two shorter of the sides. The only possibility that worked was C, and the lesson there, the valuable thing is that, as I always say, I say it to myself and I say it to other people, the right answer to the wrong question is a wrong answer. If I think that I've answered some question but it doesn't satisfy the precise requirements that the question was asking for, I haven't made sure that my sides are integer lengths, or I haven't made sure that the shorter sides are the x and x plus 1 in question, I haven't satisfied the question right. And so no matter how much hard work I did, if I haven't satisfied the requirements of the question, it doesn't matter. The answer is wrong. So, unless I happen to get lucky on a multiple choice. So always after having, I thought that I was good to go here. Was I good to go here? Yeah. But, such that I had selected 2, but answer A is my answer, but then I wanted to go back, and even if I'd already filled in my answer, key on my test, I wanted to go back and read the question again carefully, make sure I'd answered it quickly. And as I was reading through, I was reminded about this 2 shorter sides part. So I always go back, after I've answered the question a lot of times, I'll go back and read it again and say, did I satisfy what they were asking for? So now I've done all that. I've read the question carefully through. I've basically done trial and error and crossed off all of these other possibilities as being invalid, either because they contradict the triangle inequality as down here, or they contradict the requirement of the 2 shorter sides part up here, and this is the only one that satisfies everything. I would move on in a test at this point, but then coming back at the end with extra time or post-processing after the test, I would want to do it another way, and the natural thing to do here, rather than resorting to trial and error, would be to see what I could have done if I'd stuck with my, just from a purely algebraic inequalities approach. Let's see, I knew that, I think this is my most important inequality. 2x plus 1 is greater than y. 2x plus 1 plus y equals 13. Well, 2x plus 1, I can get rid of my x here. Y is the side, the other side that the question is asking about that I'm interested in, according to the way that the question, which of the following could be the length of the other side. X and x plus 1 are the two that are given. I made up y as my variable for the third side. So it'd be kind of nice to get rid of the x's here, and I can say y equals 13 minus 2x plus 1 equals 12 minus 2x. So I know y equals 12 minus 2x. I know 2x plus 1 is greater than y, which is 12 minus 2x, which tells me 4x is greater than 11, which tells me x is greater than 2 and 3/4, but since x is an integer, x is at least 3. This is making me want to go back. Yep, here. X is at least 3. And yet, I haven't modeled in my algebraic inequalities yet. I haven't modeled yet the, I haven't put into mathematical terms the requirement that x and x plus 1 are the two shorter sides. So I also need x, well, x is less than y and x plus 1 is less than y, but knowing that x plus 1 is less than y automatically implies that, well, of course, x is less than x plus 1, so of course x is less than y. So this information is superfluous. This is really what I want. Y is greater than x plus 1, which is greater than or equal to 3 plus 1, which is 4. So y is greater than or equal to 4. Well, y is strictly greater than, y is greater than 4. So I've got a triangle with sides x is at least 3, x plus 1 is at least 4, and y, we weren't told that y was an integer, but if this x is going to be an integer and x plus 1 is going to be an integer, and the perimeter of the triangle is 13, which is an integer, so I've got 3 numbers that have to add up to an integer. So y, really, I can conclude that y also is an integer, and if y is an integer greater than 4, then y really is at least 5. These values, 5 plus 4 plus 3, adds up to 12. That's not giving me a lot of leniency room for if I've got a perimeter x plus 1 plus y equals 13. These constraints have already forced me such that these add up to at least 12. That doesn't give me a lot of wiggle room. Well, but I know that I've concluded that y must be at least 5, so that would have eliminated a and b. See if I can make sense of all of this. I feel I could close the case. I should be able to close the case with my inequalities alone. Here, going back to here, I said that y equals 12 minus 2x. Negative 2x, I'm trying to use this information here. Negative 2x, if I multiply this inequality, I just called it an equation, but it's not an equation, it's an inequality. If I multiply this inequality by negative 2, I've got negative 2x less than or equal to minus 6. If I add 12 to both sides, 12 minus 2x equals less than or equal to 12 minus 6, which equals 6. So y equals 12 minus 2x less than or equal to 6. So y, okay, I can combine this fact with this fact and say that y is between 5 and 6. Well, that's narrowed things down for me enough to the point of being able to conclude that this would have been my only possible answer. I'm just curious, would it have been possible for y to be 5? I don't think so, because that would have violated the integer constraints on x and x plus 1. If y was 5, that would imply 12 minus 2x equals 5. 2x equals 7. X equals 7 halves, but we said that x was an integer, so that's not possible. So really the only possibility is this one. Now the steps that it took me to get there, let's see, I had, if I did it in terms of just algebraic inequalities, I mean, it took me all of this. Now, if I'd been real clever, if I'd been able to just, if I'd been smarter about it, all of this information probably could have been condensed into something much more precise. But in any case, oh wait a second, can I eliminate that whole thing? That guy didn't belong in there. My trial and error, I had 5 trial and error cases. These were my, well, I had to use this information either way. So my algebraic attempts were, I used that information either way. So I either had this blob here or this blob here, and I really think that the trial and error required less work, and that's kind of why I jumped over to it. I had a sense that I could figure out this answer in pure, just using inequalities alone, but there was enough, I had a sense that it actually might be easier just to do trial and error, and I think that paid off, because maybe somebody else whose brain works differently could have made this whole inequality business go a lot faster and a whole lot smoother. But for me, this process, although I was able to do it this way, that's a bigger blob and took more time than this smaller blob over here. And so my intuition to resort to trial and error for the sake of expediency was probably the right way to go. But in any case, at this point I've solved the problem in at least 2 different ways, and I've done a substantial amount of work to constrain what my values of x and y could possibly be, and so I'm confident that I've got the right answer.